Great. Good morning. It's kind of interesting having to present on the second day because after free beer the night before, what you discover when you wander in here is for those people that are watching the live stream, there are actually only 3 people in the audience and the rest are like Mystery Science Theater 3000 cutouts. So I was trying to find something relevant yesterday to link this interesting topic of cloud computing to stuff that's going on in current view, and I stumbled across something on MSNBC which I thought was actually far more interesting. A man pleads guilty to driving while influenced in a lazy boy, and this happened yesterday. Now this happened in anybody from Wisconsin? Because you're really, oh, that's awesome. All right, so the thing that's most interesting, besides the fact that this guy drank like 9 beers and cruised down the street and got pulled over in a lazy boy, is the fact that he had to drive it to the bar in the first place, and everybody kind of thought that that was just fine. So I find that really interesting. It has nothing to do with cloud, really. So we are going to talk about jumping the shark, this definition of cloud, issues, again, that pairs up really well what we just heard about in terms of trust, and then talk about this analogy of stacked turtles and cloud ponage, as we like to call it. So when faced with the dilemma of presenting to a bunch of people about what cloud is, there's the obligatory set of definitions, and you're not going to escape from them today, unfortunately, with me. I'm going to give you some, but they're relevant for setting up the discussion. Anybody know, by the way, where the phrase "jumping the shark" came from? Yeah, 2 or 3. Well, it's actually there. So the writers ran out of a set of ideas for stories on Happy Days, and so they basically said, well, we'll have Fonzie jump a shark on water skis in a lake, and that was where jumping the shark came from. Believe it or not. So the issue with cloud computing is that there's 2 very interesting perspectives when it comes to definitional nuance of cloud. You have the technicians or the provider's view of cloud, which is very precise, very empirical. So this is in this definition that I genned up graphically. You've got deployment models, delivery models, essential characteristics. When you ask somebody who is technical, what is cloud, give me some examples. Usually they talk about Amazon Web Services, Google App Engine, Salesforce.com, things that ring true that you hear about in terms of service provision in cloud. However, there's an interesting set of collisions also from the consumer's perspective, which really lends itself to some interesting discussion, which is the fact that anything that a consumer uses that connects via the internet, that interacts with or operates on or stores their data, is cloud, right? So that becomes, and that sets up some very interesting definitional issues, not the least of which is stuff like that, where we talk about, I couldn't resist, I'm sorry. You talk about a service that's connected to the internet and it's cloud, and then it's the death of cloud when something bad happens. So we're going to kind of get through some of this fog today and talk about some of the realities, but some of the things that really do matter from both the perspective of consumers and technicians. But because most of us are technicians, we're going to kind of get to the heart of the matter here and talk about cloud. So there are 3 models, basic models for cloud delivery, and they're categorized in terms of these delivery models. It's called the SPI models: software as a service, platform as a service, infrastructure as a service. And those 3 things are actually targeted very specifically in terms of offerings and how they're presented to 3 very distinct groups or audiences. Software as a service is really targeted towards end users. Give me the flexibility of an application delivered in this thing called the cloud, and I'll use it. It'll take my pain away. Platform as a service is delivered or targeted towards developers. Build your apps on the cloud to supply applications to end users. And ultimately, infrastructure as a service is really this notion of system administrators. How do I take what I today operate internally and put it in the cloud? But what does this really look like to somebody who has to understand from a security perspective what cloud means in these 3 models? So I genned up a kind of a taxonomy, ontology of what cloud looks like. So from an infrastructure as a service perspective, very similar to kind of an OSI model approach, you've got facilities, the compute network and storage, hardware layer that sits in them, a kind of intermingled layer of abstraction and core connectivity and delivery, and then a set of APIs to manage it. That abstraction layer could be virtualization, it could be multi-tenancy in databases, it could be anything that allows you to actually add more than one level of service for more than one constituent customer. So platform as a service is really infrastructure as a service with a set of integration middleware development framework hooks on top of infrastructure as a service that lets you write and bind and develop applications on top of the infrastructure as a service. And software as a service ultimately is then the rest of the stack: data, metadata, content, applications, ways of presenting and interacting with data. So with those kind of pictures in mind, where you look at that Lego approach, when we think about what security or how security is impacted in these three models, in this derivative compute model, we kind of need to understand how it changes, where responsibility and accountability change. So from the perspective of infrastructure as a service, the line of responsibility for security administration is drawn right above the API level. So anything below the orange line, the provider is responsible for. The VMs and containers, OS and applications and data is really left up to the user to manage and secure, right? So the general focus here is on virtual machines in a virtualized environment and things that are guest-based. When you look at what that means from a service contract and enforcement perspective, here's a good example from Amazon. The part in yellow, you bear sole responsibility for adequate security protection and backup of your content and applications. Okay? So from the perspective of how you think about what security means at a contractual level, it kind of abstracts or hides a lot of the moving parts when you think about how teams approach securing infrastructure as a service. Platform as a service, programmatic, the kind of programmatic security, again, the line moves up a little bit. The consumer is still responsible for then dealing with applications and data, right? So you are responsible, strangely enough, for making sure that applications and data are appropriately protected. I went looking for the terms of service for Google App Engine, and I got this. You are responsible for security of your passwords and for any use of your account. That's as much as I could find from the perspective of security clause as it relates to what they delivered. Doesn't leave me with a very happy feeling. When you look at platform as a service, and Robert Fry from Salesforce is going to present later, we were talking about generalizations, and these are generalizations. But for the most part, when you look at a SaaS offering, you are essentially allowing the provider of that SaaS service to kind of own the stack and provide you with the security up and down all of the feature sets. Now, there are things that you are still responsible for in terms of how you interface with your users, how you might take care of some of your data. But for the most part, up and down the stack, software as a service is all-encompassing from a security perspective. Now, to Salesforce's point and credit, the part in yellow here was probably the most specific set of things that were contractually stated that they would do. We'll take care of confidentiality, physical security. We'll do the best job we can in these particular areas, and they're a little bit more specific than what you get in infrastructure and platform. And that's interesting because when you think about what both the technical and the contractual issues mean to security, and you look at these three models, first of all, the lower down the stack the provider stops, the more responsible for securing those applications and data you are. That should make sense. When you think about what it means tactically, the software as a service layer, you're really RFPing or contracting it in. You're basically agreeing or stipulating terms in a contract to ensure that your apps and data are safe. And here, you're still, for the most part, responsible for building it in. So the level of effort and the level of control is really proportional to the service delivery model. And that's really, really important when you think about cloud because depending which delivery model you use, available compensating controls may be kind of at the level of good enough given the amount of mass scale, or they may not exist at all. So as networking, as a lot of this functionality gets abstracted away, where we're exposed to less and less of the moving parts, your ability to integrate compensating controls and what you would ordinarily do in a physical environment that you own is limited. With that, you may see more and more APIs and interfaces, both open and proprietary, but what it really means is that we ultimately come down to putting our applications and content in somebody else's care, and it comes down to trust, right? This is kind of an overused cliche, but what trust means in relation to cloud has really taken on a new dimension because it's starting to cause people to think very diligently about what it means if a large percent of my application and content moves elsewhere. So when we look at trust, every operation we have today in some form or function comes down to trusting somebody else. When it comes to cloud, when it comes to anything connected to the internet, it's trust in providers, trust in protocols, trust in hardware, trust in software. It's not an unfamiliar term. What is interesting, however, is the definitional nuance between trust and control. They mean different things. People merge them together. So here's the problem. Trust is one thing, but control is another. And ultimately, cloud is all about gracefully losing control. It's surrendering your data, your applications, and your content to somebody else, right? From a security perspective, this makes people very uncomfortable because control is really an emotional issue. I'm not going to put my data there because they can't take care of it as good as I can, right? So the way we deal with that is by ensuring we have transparency and visibility to process, and while the moving parts may be abstracted, we're really, really interested in what that means in terms of how I can take, from a compliance perspective, my existing operational models, my existing controls, and either compromise by making risk decisions, or be able to deploy new technology that takes care of some of these things for me but allows somebody else to do it. So this notion of stacked turtles, and this is a follow-on to my presentation that was that had frogs as a theme, so I used the graphics instead of turtles. But has everybody heard of the stacked turtles analogy? Turtles all the way down, like a game of Jenga, right? You pull one stick, they all fall. One turtle at the bottom falls, they all fall. So the notion here is that when we look at cloud and we look at what it means, cloud is not a technology. My coworker James Urquhart says, and very wisely so, said that cloud is an operational model, not a technology. So we really have to understand what it means from the perspective of how operations change. So when it comes to cloud, we are really talking about stacking clouds on clouds on clouds on clouds, multiple dimensions of things, staggering amounts of interdependencies and complexity obfuscated by a nice tidy bundle in a web browser. And that's problematic because we are building on what amounts to a very, very shaky foundation. We take it for granted. We all nod. We all know that the internet is, pretty much unstable in many cases, and there's a lot of handshake deals that go on as it relates to how our data gets from point A to point B, but we accept it. It's reasonably resilient, but the reality is we are talking about now wholesalely moving data and applications potentially outside of my control and outside of my ability to affect compliance, security, and do what I do today. And it's based on stuff that is, and a set of problems that we're going to discuss today, both directly and in analog, that should make you a little concerned. So there's an airline in India, and there's called Air Deccan, and I found this rather interesting because there's an ancient Hindi myth that says just because you can does not mean that you should fix an Airbus A320 that flies at 36,000 feet with a piece of duct tape. This picture was unfortunately taken by a gentleman waiting to take off out of the cabin window. So I found it a profoundly interesting analogy that, from the perspective of cloud, we have this fantastic capability and we're pretty much patching holes with duct tape. So when we think of this in a more relevant analogy that we get to participate in every day rather than sitting there watching somebody repair your plane with duct tape, I thought about, hey, when we drive down the street, the only thing that essentially prevents somebody else coming at 80 miles an hour and hitting me head-on is the fact that he or she wants to get to their location as badly as I do, and those really, really secure yellow lines painted in the middle of the street. When something like this happens, we react one of two ways. We sweep up the mess, or we put in Jersey barriers, sometimes both, and we just hope that people don't hit the Jersey barriers. The reality is it doesn't really solve the problem. So there's an awful lot of, again, reliance on the fact that we hope people do the right thing. Unfortunately, that's good for a small percentage of the audience, but the reality is that when we think about our adversaries, it doesn't really apply. And so when we look at, for example, what this means to providers of cloud and virtualization services, I love that picture. So far, we've gotten, with brand new technology, hypervisor vulnerabilities, lack of trusted computing-based implementations, a lack of standards, introduction of monocultures with brand new sets of computing resources that could be tens of thousands, if not ultimately, as Google states, up to 10 million compute nodes, information leakage, substantial downtime, and a ton of security by obscurity. Trust us, it's secure. When we look at how the security industry has responded over time, it's kind of easy to understand how that's happened. So these rings represent a continuum. The outer ring is how users have interacted with their data. Ultimately, as we move in closer, one ring lower, it's how we have typically enjoyed compute. Then there's how data has been either centralized or decentralized, and then bandwidth in terms of speed and reliability. So we started with the ever-friendly mainframe, very centralized data, centralized compute, slow for the most part. We went to minis and micros. We got the client server, a little bit more distributed, more powerful on the end node, more compute resources that were connected to the network. Web 1.0, we started much more distributed capabilities with protocols that were stateless, ultimately then getting faster, more reliable. Web 2.0, thinner clients, but really interesting models for program language program language development that allowed us to execute some stuff, like, for example, Ajax, locally, but some distributed, with data distributed and local. Very interesting model. And then virtualization kind of injected some distribution, but through consolidation at the same time. And now we're kind of at this point where we have the cloud, right? And we have these two very divergent models, neither of which we are very good at securing. And to that point, the security industry's response thus far for each one of these transitions has been this magical and impervious device called the firewall, right? And Gunnar Peterson did this great thing. He built this table that said, look at all the cool development languages we've had over time, and look at how remarkably consistent the security industry has been. And that's pretty much the extent of it, right? Variations of a theme of network firewalls and SSL. That's where we are. That's our solutions today, for the most part. And that model just doesn't ring true. It doesn't, and yet we don't push, we don't stretch, we don't essentially encourage providers to do things differently. And for cloud, we really need to. And that's kind of the premise of what we're going to talk about. Because when we look at what I call the hamster security sine wave of pain, and we look at how we've invested in security controls over time, and my apologies to Andy Jacob, he came up with the hamster sine wave of pain, we move from host security to application centricity, to information centricity, to user centricity, to network centricity, each of them having their relevant time in the spotlight. And effectiveness for 5 minutes of 15 minutes of fame here. The problem is it goes on and on and on and on, because what's interesting is if you overlay this notion of disruptive innovation, which is almost, and it's kind of a smooth curve, but we're almost 180 degrees out of phase every single time with when a disruptive innovation hits. So in this case, I picked one, virtualization. So as we focused on network centricity up here, being able to apply things and correct things at the network level as we move through this evolution, all of a sudden virtualization comes along, claws the network into the host. The network doesn't look like what it used to look like. It doesn't have visibility. We can't manage it the same way. We can't secure it the same way. We are 180 degrees out of phase. We wonder why we don't time this thing right. Sometimes we hit in the middle, but then we get another big burst of disruptive innovation and the cycle starts anew. So the challenge here is for providers and the security industry to get together and understand what disruptive innovation means to the controls and the solutions they provide. And to give you another practical example, we take this virtualization and cloud theme to its natural progression. And we see this thing, what I call kind of converged simplexity, right? The most, it's an incredible amount of convenience and power when you look at how we are taking compute, network, and storage and smooshing it down and integrating it into single platforms. And so the issues we have then start to intensify, especially when you look at the fact that as the network speeds and feeds go from 1 gig to 10 gig to 40 gig to 100 gig, and you see folks essentially flattening out and going back to really, really flat layer 2 networks, giant broadcast domains to enable things like virtualization and vMotion capabilities, and the need for terabit switching fabrics at layer 2. How the heck are we supposed to take solutions today that barely run at speeds that function, to protect a small amount of hosts, run at wire rate while applying security in balancing connectivity? And so the reality is this is really a squeezing the balloon problem, right? We're constantly playing catch up on that hamster sine wave of pain. There are some folks that when you get into arguments, look at and make a very good claim that the internet as it is today, and we're talking about the internet because I'm really focused on public clouds, is just fine, right? There's nothing wrong with it. It will heal. It has made incremental progress. But the amount and the rate, the velocity of disruptive innovation is starting to really show its age as it relates to what the internet's able to deliver. No pun intended, Vint, sorry. So I like to take this problem of security and the cloud and chop it up into 3 buckets, because if I throw all the stuff I just threw at you in one bucket, you probably want to just start drinking, or you're just going to give it up because you just start chasing your tail. So I like to separate problem sets out into graphical form. So I built this visual, and I separate things into 3 layers. Infrastructure, another one called infostructure, another one called metastructure. And the definitions are pretty simple. Essentially, infrastructure are compute, network, and storage, the cogs and moving bits. At the top, at the crest, you have content and context, apps, data, metadata, service delivery functions. And in the middle, we have the glue and guts, the protocols that deliver these things. Now, prior to virtualization, metastructure like BGP, IP address management, identity management, when we didn't have mobility, glued those 2 things together. They were, static affinity between infostructure and infrastructure. So we didn't have to think about how things moved around too much, because they were pretty much, you plug it in and that was it. But now that we have mobility, we have virtualization, the actual pods and contents can move, that middle layer is really, really screwed up and showing its age, right? And each one of them have problems of their own, but when you group them together and you start thinking about interdependencies, turtle, turtle, turtle. And we're going to get into each of those with some examples. So when we talk about owning the cloud, we're going to separate them into these boxes. Prior to do that, I have a public service announcement that suggests I'm supposed to tell you that the cloud is all about, there's warm and fuzzies, it does wonderful things, there's agility, flexibility, cost savings. I can do, even from a security perspective, there's very cool things that I ought to be able to do with cloud. And that's very true. And depending on the model, you might actually get to enjoy some of these. But the reality is, again, back to the stacking the frogs problem, we look at the shiny kind of thing, the mockingbird approach, looking at the shiny jewelry, and we kind of forget about the stuff that was swept under the covers. So not the least of which is we have all the same familiar security challenges that we have in cloud that we have in traditional IT. Right? All of those things still exist, and in fact they intensify. And all of the tactical security issues that we have to deal with still exist. They don't go away. In fact, they intensify. So when we look at this, what's old is news again. So when we think about this notion of why I titled it the way I did, besides getting you folks up to come and see this talk, is the notion that it really is about these clouds on clouds on clouds, different interpretations of what cloud means and how these interdependencies relate to one another. We have been dealing with this kind of notion of the amorphous perimeter, reperimeterization, how the inside and outside were well demarcated by that firewall. Not anymore, right? There's no such thing as inside and outside very much anymore. And then you take that notion and you add to it multi-tenancy, where I am actually putting my data and commingling my data with somebody else that I don't know, that could be my adversary. Then we start getting to some very interesting issues that we haven't had to deal with because we've only had to deal with a single entity before, that inside versus outside model. And then you apply this notion of what I call socialist security. It's kind of the security metaphor for the Canadian healthcare system. If you got a cold, you're fine. God forbid you have to have a heart surgery tomorrow. The reality is that what you get is good enough. It's kind of free. It comes with the territory, with the service. But the moment you start putting your data in multi-tenant elastic environments, then you're getting kind of good enough levels of security. There's simply no way that your apps, your content, your data with the current set of protection mechanisms are going to be able to enjoy the same level of protection. Now, people argue with me about that all the time, and they say, well, these providers can do it better than you can. That's not a fair analogy in many cases. The fair analogy is an unfair analogy because they essentially manage a single app. They do one thing very, very well. In a typical large enterprise, I have to manage, for example, there was a quote, 800 applications with 3.5 versions on average each that they have to manage. So it's unfair to suggest that, if it's one-to-one, yeah, maybe I could argue that cloud providers could do a better or even equal job. When you're talking thousands to one, maybe that's not a fair analogy. Maybe our expectations are set a little skewed. So we have that really set of crusty protocols, and we don't integrate very well, especially from the perspective of security. And so really when you think about it, when you talk about cloud, especially public cloud, massively scaled public cloud, this comes down to the issue of how do I scale security? How do I take what I do and what I need and scale it so it is at least good enough or should be ultimately better? So an example is in order. Let's imagine that we have a fictional public infrastructure as a cloud provider. We will call them Denial Web Services because denial is not just a river in South America. And my apologies to somebody listening in the audience that I know works for said company. So virtualization, multi-tenancy, and isolation are based on a hypervisor. You get elastic compute, network, and storage capabilities. So let's take a journey. Let's think of if you were offering a set of services today, or if you were a consumer thinking about a set of services, how might these services be impacted by various levels of fail in the infrastructure, metastructure layers, and what that might mean to service delivery. So a lot of these things you'll individually and out of context say, yeah, I know about this. Yeah, that's fine. We've known about this for years. But the reality is I wager that when you put this big picture together, you're going to start thinking differently about what it means to cloud. So we'll start at the bottom turtle, and we'll think about physical fail. So I'll give you some classical examples of physical fail, not necessarily related to cloud, but just in general. So here's a co-location provider, 365 Main, hosted a large number of your favorite Web 2.0 apps in San Francisco, suffered from this really nasty set of cascading power failures that took a bunch of sites that I use. In fact, my blogging site, TypePad, was taken off the air for like 6 hours. Right? That shouldn't happen. They had multiple levels of resilient capabilities, flywheel generators, backup, diesel generators, UPSs, died off the air. Bye-bye. So all of this fancy engineering on the top level, BCP disaster recovery, didn't work so well. Rack space. A truck drove into a power transformer. Same sets of problems. Unexpected issues took down massive data centers and their connectivity. This was interesting. CI Host in Chicago was a victim of robbery. When I first did research, it was kind of interesting given the statistics because it happened to them not once, not twice, not 3 times, but 4 times. Essentially, somebody cut a hole through the wall of the colocation provider, took the staff hostage, and walked out with servers. Okay. Then we got stuff like the example with core IP networks. The FBI said, yep, we have a warrant. We're here to confiscate the equipment associated with this customer. Oh, it's virtualized. You know where it is? We'll just take the whole data center. So they took the whole data center, walked out. So you think, well, you know, that doesn't happen very often. True, you know, only 4 times in Chicago. So when you think about, so it's your data center, right, Chicago? I think good choice. Invest in concrete. You know, what's very interesting about kind of moving up a layer in terms of adding a turtle is large cloud providers, as you consolidate distributed data centers down to mega data centers, and you start thinking about what traffic patterns look like, peering and transit relationships over public internet, what ends up happening is there are a set of dynamics that are fascinating. If you have a physical failure at a colo center that has, let's say, truck container-based compute nodes that hold 2,000 nodes, and you have hundreds of them, and that whole thing, for whatever happens, somebody steals them or whatever, it goes off the air, the traffic surge associated with this failover in BCP at this level, this kind of low level, is absolutely scary because, you know, when we have natural disasters or unnatural disasters, the reality is that we kind of think, well, we'll just fail stuff over. But there's an awful lot of dependencies on what happens when we do that. More importantly, you add mobility, and as we get policy capabilities that allow a customer to dictate, I want to save energy consumption, I want to move stuff around for BCP and planned outages, and I'm actually able to move workloads, I could conceivably move an entire data center from one center to another. Huge amounts of impact on traffic flow, on peering, right, on essentially connectivity. So shared infrastructure, ultimately, when you think about what this does in these mega data centers, as we're replacing what ends up being lots of distributed data centers with very concentrated ones, the impact, the failure impact radius really starts to increase, given the density of the compute, storage, and network nodes. And more importantly, the blowback effect could be very, very huge. We don't really take that into consideration. We think, oh, it's very cool. We have these mega data centers. What happens when they fail? So this is a map of the fiber that carries most of the Internet's traffic. Very interesting things occur. It's shared for the most part and operated cooperatively. But when we have things like earthquakes in China, all the stuff in red was all the damaged fiber. So what happened to the Internet traffic that went over it? Well, in many cases, it didn't. It simply ceased to exist. We saw the anchor version of backhoe fade in the Persian Gulf, right, where 60% of, I'm sorry, I was just fishing, 60% of the Middle East went bye-bye. So what's interesting about that is when you think about this notion of shared wavelengths and bad things happen, right, what you end up with is massive amounts of dope. And so the beauty of cloud is that with the premise of infinite scale comes the potential for infinite fail, right? And again, we're like, hey, it's shared, you know, it's self-healing. Well, to a point. You know, 60% of the Middle East off for a couple of days, that's not self-healing. So let's go up a stack and add another turtle, right? So I got some friends who operate a lot of these very, very complex networks, and they use all the same infrastructure to do it. So what happens when there's something nasty that happens to this core infrastructure, right? When we have core infrastructure exploits. We generally respond pretty quickly, but when we get O-days in hardware, that's bad, right? You don't hear a lot about them, but they happen. My friends at ERNW in Germany gave a presentation at BlueHat, which was just absolutely riveting and scary as all hell, because essentially they showed how they could own entire carrier networks. So a lot of the private clouds, if you will, that present themselves as public clouds to deliver service are run over carrier Ethernet and MPLS networks, layer 2 and layer 3 VPNs, on shared infrastructure. ERNW, these guys showed that with some very, very basic connectivity, once connected to those networks, they were able to essentially redirect transparently traffic from one point to another point without the sender or receiver knowing. And not a typical man in the middle where you're actually spoofing stuff, but actually redirecting traffic. And we're able to, for example, to utilize really low-tech tools to do it. And just so keep in mind that this shared network infrastructure running over the shared fiber, running in these big shared data centers, turtle, start having staggering implications when then you add things like privacy issues, like the NSA's free email archiving option that we got as American citizens, which is fantastic. And then ultimately, when you look at some of these technologies, the resurgence of being able to use old school tools like Yersinia to do layer 2 spoofing attacks on switches. Why does this stuff work? Well, because we forget that it exists and we go for the shiny stuff. There's another layer of turtles, right? Very interesting. Take another layer up. Let's look at these providers who are using common sets of physical infrastructure, chipsets, common sets of hypervisors to deliver their service. Well, prior, when Joanna Rakowski and her team at Invisible Things Labs came up with a set of these exploits, I said, you know, not that interesting, or not that readily exploitable. But when I started thinking about the fact that in cloud, we're dealing with networks that have 40, 50, 60, 100,000, and as Google has, even though they don't use virtualization the same way, up to millions of nodes, what happens when I have a common layer that provides all of the multi-tenancy, all of the isolation, and all of the security capabilities to enable service? Well, she's been able to show Zen-based hypervisor DOM 0 escalation, where she can essentially own the version of parent partition that owns the would be DOM-U or the client VMs. VM escapes, blue pilling, inserting one hypervisor under another. So all of the security things that you think you have in place can be completely and transparently skirted, right? Then we've got ultimately bypassing trusted execution technology and Intel's chipsets, which she's shown, SMM attacks, BIOS rootkits. This stuff is real. It's able to be weaponized, ultimately. So again, shared infrastructure, shared fiber, shared networks, ultimately shared multi-tenancy from the perspective of virtualization on a common set of software that by all virtue, even though it's 40-year-old technology, is 4 or 5 years old in terms of maturity in deployment and development. So I know you love here the monoculture word, but it is an absolute reality when it comes to some of these large public cloud providers. And it's horrifically frightening. Because the reality is, besides the operating systems that run on top of these things, we now have a common set of infrastructure. So whether you're looking at the two big players in this market, what happens when these exploits come to pass? How quickly are your providers going to be able to remedy them? So here's another interesting, we'll go up a level. Add another turtle. So here is the community, set of community AMIs, or virtual machines for lack of a better description, that's available on Amazon that people have created. Windows, Ubuntu, Fedora Core. They're just packages of operating systems and hardware in what amounts to a VM, right? You download them and you just say, go, deploy. Deploy one of them, deploy 100 of them, right? Do what you want, go. You go to VMware, do the same thing. Here's a Sugar CRM, here's a couple other packages, virtual appliances that you just basically click download and start deploying. Well, let me ask you a question. When you look at this software, how do you know what's in these images? How do you know what process, talking about the SDLC that Andy was talking about, how do you know what is actually running in these things if you're not a code expert, if you don't do source review? So in fact, the guys at SensePost presented at Black Hat have they built an AMI, named it so it would be at the top of the list and made it sexy and attractive looking, and hundreds, I think hundreds if not thousands of people downloaded the AMI and ran it, right? I could install malware. I could do anything I wanted, and because there's no outbound filtering on some of these networks, it just, information exfiltration, free of charge. So here's another interesting things we bubble up. Some research was done by Aaron Tromer out of MIT, Harvard actually, I think, and where he did this fantastic set of research that, while it may not be weaponizable, it may not be practical in some senses, was able to show, for example, that on Amazon, he was able to predict, based on brute force loading, in an infrastructure that's completely abstracted from me, based on essentially being able to look at how, in the combination of IP addresses and how ultimately resources are deployed, was able to see where and which physical machine an AMI would be deployed on. But I'm not supposed to know that. So what that gives me is the potential to look at fingerprinting attacks as we move forward that says, you know what, if I'm interested in attacking you, then if I can brute force my way into understanding how I'm going to be able to place my AMIs, and I put them right next to you, and then I find an exploit based on another turtle that allows me to do something nasty to you on the same physical box, okay, that's bad. Okay, that's bad. Now, there may very well be countermeasures to this, and I'm sure there are and will be, but the point is, researchers and black hats and white hats generally think about these things in abstract terms where operationally the providers don't. And this is a great example. Fantastic research. Guy Rosen took another stab at something very similar, and it's kind of the German tank problem from World War II. The Allies wanted to know how many German tanks, how many Panzers they had. So they went through all this analysis, and this, they're thinking, how are we going to be able to do this? How are we going to be able to understand how they're rolling out these numbers of the number of tanks? It became a very simple question. They just looked at the number of serial numbers that incremented. Oh, okay. Very easy solution. So Guy did something very similar. He noticed that every time an Amazon AMI resource spooled up, it had a resource ID. So at a minimum, what he's able to do is forecast based on a response to anything, traffic, auto-scaling, which is the ability to burst up under load. He could tell how many resources were loaded in a particular period of time. Now, imagine from a fingerprinting perspective, if I'm interested in understanding how a cloud provider responds to attack based on load, based on anything, based on scale, or a customer does, how he set up his auto-scaling rules from 1 AMI to maybe 100, doesn't really matter in different availability zones. I start over here, I watch how things ultimately scale, and then maybe I launch targeted attacks while somebody's not looking over here, or I see how they respond. I'm able to better target what it is I'm going to do. Again, there are ways around this, providers, and this is maybe a short-term thing, but the point here is that, again, creativity and ingenuity trump this socialist security approach, right? Ultimately, there are always going to be smarter and better people that look at exploiting these holes. So let's take this up a level again. We'll talk about another turtle. A friend of mine, John Obereed, did a really interesting set of research, this time on VMware. He also did it with some Zen stuff too. But there's a vMotion, which is the ability to take a running image from one part of your network, and one layer 2 network, and move it across, and then kind of stop this one and start this one without any downtime. It requires today what amounts to an unencrypted network channel to do it, because it adds overhead. So essentially what they do is they kind of take this image, they bit chunk it, they transfer it over by pieces, and when it's all intact, they go. Well, what John was able to do is, see that network in the middle? Envision, let's say a shared MPLS network, for example, where he has now access transparently to those network channels. He was able to take code, as he vMotioned it, inject code in real time as it transferred, and have code run over here that wasn't running over there with no detection. If that doesn't make you crap your pants, I don't know what will. This was horrific, right? Turtles on turtles on turtles on turtles. This stuff is pretty scary. And you think, oh, well, physical protections, MPLS. You know what? If you combine that with ARNW's work, which is entirely feasible and completely low tech, you ought to not react that way. So we go up a level again. We look at how people are doing research on VM escapes. So the guys at Immunity showed their Cloudburst VM, which essentially, anybody here had any experience with an operating system that was using embedded device drivers in the kernel? Oh, yeah, kind of a bad idea, I think we've decided, right? So some of these virtualization platforms do that, sadly. So in that regard, they're able to essentially abuse virtualized device drivers and end up with VM escapes, being able to get to other VMs or even to the hypervisor themselves. Scary stuff, right? So we're going to leave the infrastructure realm now that I've turtled you out there, and you should be sufficiently interested and intrigued, and we'll go up a level to metastructure. So Uncle Dan over here has his, everything is a DNS problem, which in many cases it is. So DNS cache poisoning, right? Fantastic set of things. When we talk about trust, I want to talk to Bob, Bob.com. I just trust that with a padlock in my browser that Bob.com is who he says he is. And in fact, it's the certificates, right? It must be true. What could possibly go wrong? So Dan's DNS attacks, you look at ERNW's BGP or Capella and Pilasoft's BGP attacks like they did at BlackHat, where they redirected all the BlackHat network traffic to New York. Nobody noticed. Or when Pakistan blackholed with a more specific route, they didn't like, the latest Britney Spears video, so they said, oh, we need to do something about this. Please get rid of YouTube. Sure, I'll inject a /24 for all of YouTube, which then routed all of your traffic to Pakistan, which for YouTube was amusing, since as much as I like Bollywood and that sort of thing, didn't really give the desired effect. So then you couple that with man-in-the-middle attacks. You couple that then with Moxie Marlinspike's work with SSL TLS, where he was able to do, in conjunction with, for example, Soderov stuff with rogue CAs, chain certs, null certificates, where they're able to spoof things for phishing attacks. All of the trust models we have at the metastructure layer, BGP, SSL, DNS, essentially once you're part of the club, once you are connected to the network, once you're able to announce and inject things like BGP routes, there ain't a hell of a lot you can do to prevent these things. There's response to them, but again, the crusty old protocols never really built in enough authentication and authorization to think about what these attacks, in some cases, very low-tech ways, do. So again, we're relying on all of this stuff still, right? More turtles. So as we go up and we think, well, a lot of this stuff will be fixed if we can just get enough APIs and enough interfaces, open or proprietary, to allow me to do this. The reality is that if, when we start looking at the fact that there are literally 13 kind of standard bodies or organizations today working on cloud interfaces, ultimately it will settle down. But what we have now at the level of trying to manage and get visibility into the infrastructure layers and the metastructure layers, it's a really, really nasty problem because we don't have that visibility that we've lost. So if complexity is the enemy of security, what does abstracted simplicity give me, right? Where it's all hidden, right? That's even worse problem to me as a security professional. I want to be able to understand, even at an abstract layer, what's going on, and I can't. So to make it worse, we have a bunch of developers who want to rightfully be able to point, click, and deploy from an IDE. Don't want to care about infrastructure. They shouldn't have to. To them, things like cloud is just a platform with API and interfaces and somewhere to host their code with a socket to write to the network. And that's fair enough, right? They don't want to think any differently, and nor should they really from that perspective. The interesting problem here is that metastructure should be transparent. So they write to a socket and away it goes, and they just expect stuff to work. So the applications are kind of engineered separately from the stuff that binds them to the infrastructure. So if infrastructure breaks infostructure and metastructure breaks infostructure, then what you end up with is a game of rock, paper, scissors. Right? We have these dependencies between how we programmatically address this stuff, which again, if you think about what platform as a service gives you, when it kind of unifies infrastructure and platform, there's a really good opportunity to fix some things that today, for example, we don't do a good job of. But to make things more confusing, when we think about the availability of a service or an application, we typically, we usually blame the firewall when something stops, right? But the reality is, it gets very difficult when you start to think about root cause analysis and who's to blame and who owns failure in cloud. So a great example is this. So Bitbucket. Bitbucket was is a source code repository where people write code and check it in and uses cloud services. In fact, it's based on Amazon. And so they were down for almost 20 hours, right? And there was this thing in the background is their blog detailing and chronicling the entire event about why they were down. At the end of the day, what they noticed in this highlighted portion that I put up here on the screen is that they were essentially a victim of a massively scaled DDoS attack. Okay? On a network that, from their opinion, and in some cases how it's marketed, should not be victim to a DDoS attack. I'm supposed to be protected from these sorts of things. Now, there is an ownership issue here between if you run a single instance or a couple of instances only, and you expect to be resilient against hundreds of megabits of traffic, whose fault is that? Is that the provider's? Is it yours? Did you think this through? The reality is there's some shared issues here about who owns this failure, where the lines get drawn, how things are responded to, how you do incident response, how you've architected your network. So the reality is, I make the point that if you single source your provider, you are just as at risk and going to have your ass handed to you on a plate one day because you are not thinking and building architecture. You assume the cloud's going to take care of it for you, and it doesn't necessarily. So when you looked at this, people kind of grappled for what the answer to this problem was. Let's blame Amazon. Let's blame Bitbucket. Well, the reality is Benjamin Black made a great statement. He said, marketing is not a root cause. If you believe what you hear, then you deserve it. Fair enough. So we'll go up the stack a little bit, and we'll think about things that you might not think about in terms of, why I might be presenting them at the infrastructure, the apps, content, and data level, but they might make a little bit more sense. So people think about cloud, and they say, oh, well, either they have the opinion that nothing changes when we talk about app security, web app security, or everything changes because it's cloud. Right? In some cases, we see N-tier application development get a little bit fuzzy in terms of where these tiers might exist and how they intercommunicate. And it's the kind of the revenge of the dark Sith Lord of service-oriented architecture. Right? They figure out, everything's different, but in some cases, everything is the same. So the point here is if you don't have mature practices when it comes to your development of either non-web apps or web applications, and you launch and you deploy on an environment that is connected to the internet and the cloud, you still have to fix your security, right? In many cases, we can't lean on crutches like web application firewalls to do filtering because they don't exist in cloud environments in many cases. So information exfiltration with an anonymous source, with anonymous connectivity, instead of being able to chop down who has access to your data, now the potential is if you misconfigure something very easily, you set up the wrong security zone, you don't put an appropriate filter in place, the ability or capability to have your information exfiltrated gets even larger. I like this illustration because you might think about botnets as being kind of an infrastructure issue, but today, if I'm a bot master and I want to build a huge botnet army, I compromise what? Your end nodes, your PCs, right? I have to go through a lot of work. I have to make you do things like go to a porn site and click on something. A drive-by attack, right? I send you an email. It's a lot of work. Well, what if I just steal a bunch of credit cards and I go to my favorite infrastructure as a service provider and I say, yes, please, here are 400 different accounts I've just set up. Each one of them I'm going to auto-scale 100 different machines that are capable of generating, a couple hundred megs of traffic each, right? I don't care that if this attack lasts 5 minutes, I'll just keep ping-ponging and scaling them up, and you don't know whether I'm a good guy or a bad guy because you don't know John Smith from Tom, Dick, and Harry, right? So I can build a massively scalable botnet in a matter of minutes if I so desired. And you think about the application of what that means to security and how we counter things like malware and botnets, you start thinking, this platform in all of its agility and flexibility is wonderful, but it also yields interesting application challenges of another sort. So we've all heard about click fraud, right? And there's various ways of generating click fraud, either with people or now with malware. In fact, the study has shown that a lot of the malware, the click fraud is coming from malware that's doing it instead of people doing it. Well, I came up with this theory of instead of DDoS, distributed denial of service attacks, I call it EDOS, economic denial of sustainability. So in an environment where you use a cloud provider that charges you based on compute, network, and storage usage, could you imagine if you're my competitor and I set up either a botnet, internal or external, and I make it even low and slow, but I generate enough background traffic to drive your utilization up and your build, and you say, this is awesome, my marketing campaign is working, and you auto-scale. And that bill that you were expecting for $200 with offset revenue from your purchases, but for which you don't have good end-to-end instrumentation and telemetry to see that somebody that came in the front door actually bought something in the back door, at the end of the month, when you get your bill for $20,000, how are you going to pay that? Right? So this notion of the extension of cloud as a platform enabling things like click fraud is incredibly frightening. Right? So these are kind of shiny bits, interesting things to talk about. But I reference back to the first point in terms of web application security and application security. You know what? We still have, look at the OWASP top 10, right? Buffer overflows, you're kidding me. SQL injection, right? Why have we not fixed these things? It's mind-boggling, right? We continue, even with SDLC, even with the great work you guys have done over the years in SDLC, we still have the other problem, the ISVs that Andy referred to. So this is really still problematic. And then you look at kind of a layer 8 problem, which is this notion of kind of how cloud services and policies are governed. And I like this. This isn't infrastructure as a service, it's a software as a service offering, but there was a little kind of blurb on the Google support site. Hey, I just want to let you guys know, you might not see this anywhere else, but in 2 weeks, we're changing our policy. Anything that you link to externally, accidentally or on purpose, or that somebody else does, just the link, just the URL. If that is linked to externally, it is now crawlable by Google. So your private Google Docs that used to be private, if somebody has shared the link outside and it is crawlable and they put it on a website, now crawlable. I was very interested the other day when I saw a news story that that Google voicemail messages were now, the transcriptions, were now crawlable. Well, it's only crawlable because somebody decided to share the link, and that's a feature. Oh, I want to make voicemail available to you. So if you do that, and you're unaware of the ramifications of a policy change at this level, all of a sudden, all the security controls, all the exfiltration guards, all of the security manifestations that you put in place go bye-bye. Has nothing to do with controls or platforms or governance. It's one stupid click. Share this, please. Okay. So this is really, really interesting. Another turtle, right? The other thing I have a real problem with is something I call misinfostructure or infocalypse, right? The reality is you have these Web 2.0 apps done by some dude who eats pizza and drinks way too much caffeine, scales, gets a valuation of $47 billion, has a service that all of us use. It's really kind of crappy architecture built on even crappier architecture that isn't even cloud. It gets confused in that consumer sentiment with being cloud. And then what you get is what I got yesterday morning, which was, ha-ha, it's overcapacity. That doesn't happen in cloud, does it? Infinite scale. Well, the problem is, by setting expectations that everything is cloud, when that happens, people go, oh man, that sucks. The consumers do it, but what's even more funny is when the providers do it. Because the providers, as cloud providers, you can't have it both ways. You cannot tell me that you have service superiority and availability, better security, better performance and cost, and then give me 1990s SLAs, give me outages and breaches, give me a really lacking level of support unless I want to pay more for it, but then tell me, guys, we're just IT, fluffier looking version of IT. They go down, so we can too. Your expectations are just too high, but we're still better, so you should still use us. Really confusing set of messages, right? Doesn't work that way. Either you're going to be able to deliver and define what my expectations should be, or you're going to be facing people constantly throwing back stories like, cloud isn't ready, cloud isn't ready. Well, I only have a short time, so I wasn't able to talk about some really, really nasty things like certificate issues, identity access management, SOA web services, storage security, encryption, interoperability, portability, vendor lock-in, all of these things, huge topics unto themselves, right? Because for the most part, people forget about this stuff. It's hidden, it's obfuscated, it's abstracted. And the sad part is that we're so focused on the shiny new bits that people are wrapped up in the newest, latest exploits, many of which I've brought to bear here, which are kind of common extrapolations of existing technology, existing operations, existing exploits, but are just spun a little differently. The reality is we need to fix the things that we haven't fixed already, that we know about, that we actually know how to fix. I often ask, where is the threat modeling? Where's the risk analysis? Where's the stuff that you would do pragmatically when you go to cloud? People are essentially looking and making decisions based on cost alone, or agility and flexibility, not understanding what that means. So if we look at a summarization of some of the stuff I talked about here, a lot of this stuff, not new. Not new at all. Right? Operationally, it's going to have profound impacts on what cloud delivers to us over time. So when we look at what solutions we have today, we're pretty much at the mercy of what cloud providers build into a lot of their fabrics of service offerings. In some cases, if you're virtualized, you get to deploy virtual appliances, you get to leverage APIs at the hypervisor layer maybe, you get to exploit your ISV communities, maybe you leverage trusted computing-based solutions as they become more available, as the hardware is upgraded and can take advantage of it. But the reality is these are new solutions to old problems that we still haven't fixed. To be fair, there are a lot of good things that come out. Cloud and virtualization are great forcing functions. They are causing people that wouldn't ordinarily think about security to say, wait a second, what does this mean to me? Sometimes nothing, sometimes everything. The reality is really bad things will happen, but really good people are starting to pay attention, and we're getting eyeballs on these problems. You'll find that a lot of what we have today already works in the cloud, but operationally, we may have to give up some of that control and think about what we do and how we do it differently. And that, I think, is the challenge. So when we look at what we are doing, the infrastructure layer, we have all these converged compute, network, and storage capabilities, which allow us to kind of better focus and concentrate our security efforts, which is useful, but adds some complexity. The virtualization platforms are evolving, as are next-generation networking at the IP layer with our service providers, which are giving us better visibility, better insight, better resilience in some cases, so long as nobody steals your servers and breaks into your NOC. At the metastructure layer, we're still kind of crippled. We're looking at some extensions to amend the protocols that we currently use. So we have things like DNSSEC, BGP extensions with authentication, IPv6, new protocols like Lisp separating the routing from location, APIs and interfaces that are being built into cloud services. But for the most part, we're kind of polishing a turtle. And then ultimately the infrastructure layer, we still have buffer overflows. This is just maddening, right? I could stop there, but the reality is we're depending upon, in many cases, services that are browser-based. The browser battle, as we've heard for a lot of the presentations over the last 2 days, is lost in many cases. It's very difficult for a user to know what's good, what's bad. So a certain amount of intelligence needs to be built into the infrastructure to help make those decisions if users can't be trusted to make them themselves. We're also applying this kind of layer 1 through 6 solutions to layer 7 and 8 problems, which historically is not shown as being very useful. And the infrastructure layer is still completely and totally disconnected from the infrastructure and metastructure layers, which again, looking at the evolution of how the SPI models are evolving, Platform as a Service has a unique capability in some cases to solve problems that the other two offerings can't. Because we have hooks into a developmental framework that allows me to implement controls in a more focused way that kind of unifies the infrastructure, the infrastructure with the metastructure and infrastructure layers, it's a unique situation. But when people ask, what do I do as a security professional, as a provider at any level to get a handle on what this means, you should check out the Cloud Security Alliance guidance. So full disclaimer, I'm one of the founding members. I'm also the technical advisor for the CSA. We have vendors, we have end users, we have government organizations. It's all volunteer effort. We put out a 83-page white paper on guidance in 3 domains: architecture and framework, governance, and operating the cloud, that talk about the impacts of what cloud computing means across all these different 15 domains. And the version 2 guidance will be coming out in about the next month or so. We have lots of ties with regulatory compliance and other organizations that are giving really valuable feedback in ways that are letting people understand at a less technical level all the turtles I just kind of talked to you about. So, ultimately in closing, we created this mess. It is really our responsibility to help clean it up. Cloud providers especially have an opportunity to make things better in ways, given the centralization, given what they're able to do in terms of service delivery, that we haven't been able to do before. So in wrapping up, the reality is the attacks ultimately on cloud infrastructure, as well as people using cloud services for evil, is already here today. Let's not fool ourselves. It's a brilliant platform that makes lazy people even lazier. Hybrid security solutions are needed to bridge this gap between the physical and the virtual. Ultimately, what that means is we've got to challenge service transparency. We need the capability as a customer and as a provider to automate a lot of that visibility and gain some of that back. So, for example, I've been working with a team that is building something called the A6 API, which is audit assurance attestation API, if I left out a word. But the point here is to build a standardized way of including APIs in all levels of the SPI frameworks that allow the providers to automate the capabilities to do security things that they don't do today, as well as allow consumers to automate that process to get the visibility back in an abstracted infrastructure. So this is a huge piece, and all of the stuff like the OCCI, the Open Group Framework, all of these open cloud standards that are working now with vCloud, for example, the DNTF, are ways of trying to make sure that we gain back this visibility as the abstraction continues. So providers, you have the chance to really make a difference. And I count Microsoft as a provider. It is really, really important that besides operating systems at the consumer level that run on machines and at the server level, that as services are brought to bear, like Azure, that things are thought about differently in a way that allows trust, transparency, and visibility to continue to make headway rather than to get surrendered. It's kind of this subpar effort, right, where good enough is good enough. So if it comes down to trust, ultimately, what are we going to do differently about who we trust, how we trust, and why. So hopefully I've given you enough to chew on, enough to think about in terms of these turtles, about how all of these services are interrelated and how cloud as an operational model adds wonderful benefits and capabilities, but does not lessen our need to solve these problems. So I'll be around for the rest of the day. My contact info is is on the screen. I got my work address. Twitter, I have my own dedicated set of servers that essentially process my never-ending stream of tweets. Phone numbers there for you, email, and my blog, which I write a tremendous amount on in terms of cloud security. So thank you very, very much for suffering through this. And Billy Rios and Nate will be giving another great presentation, as will Robert from Salesforce. But thanks very much for your time.